LeetCode 936, stamping the sequence. So in this problem, you're given a target string of lowercase letters and you're given a stamp. And at each operation, you can use your stamp to print the characters on the stamp into your current string. So for example, at the beginning, you just have an empty string or like some placeholder character. And then if you stamp at the position 0, you get something like this. And then if you stamp later on, then you overwrite whatever was there previously. So for example, here we're given the stamp ABC, the target is this, and the output can be this because you can stamp at the position 0 to get ABC, and then later on stamp at the position 2 to get ABC. So everything gets overwritten. And the cool thing about this problem is that unlike many other problems here, you can just give out any answer that works as long as it's not overly complicated and too long. So like you don't have to give the minimum amount of operations to do it or anything like that. And also the constraints are pretty low. So the target length is at most 1,000, which is not too big. So actually this problem is kind of on the easier side of the hard problems because it's one of those problems where the key idea and the hard thing to come up with is that instead of stamping from an empty string, you want to remove stamps from the already built target. And if it is possible to do so, then you will return the answer. Otherwise, you'll have to return an empty array. Okay, so yeah, instead of trying to stamping from the empty string to the target, just work backwards, start from the target, and remove stamps until you get to the placeholder sequence. Okay? So yeah, that's what we're going to implement. So first of all, we're going to treat some functions like black boxes because you don't have to understand them yet, but then we are going to implement all of the functions. So first thing that you do is you split your target so that you can now edit it, because in JavaScript you cannot edit strings for some reason. So yeah, you split it, so now you have an array of characters and you can edit it. And now you have your result, which is going to be what you will return at the end. And then we have a visited set, or an array or whatever. You can use any data structure you want. So this set will tell us the indices that we've already stamped. And there is no point to stamp an index twice with the same stamp, right? So we don't want to do that. That would be a waste of time. And then we have the amount of letters that we need to remove. So as I said, we're going to work backwards. So we're starting with a target string, which is full. And we want to get to a string that is empty or full of placeholder characters. So this to-do variable here is telling us, okay, you still have this amount of work to do left. And then we have another variable that tells us if we've made progress since the last iteration. So we're going to have an iterative loop. And at every step, we want to check if we made something or if we are just stuck. And if we are stuck, then it means that the problem is impossible. And so we're going to have to return an empty array or whatever. Okay, so now comes the main loop. So as you can see, we have two ways of exiting the loop. So one way of exiting the loop is if to-do goes to 0. So we don't have to replace any more characters. We don't have to remove any stamps at all. So we've finished. And so that would be a valid way of exiting the loop. And the other way is not having made any progress. So if in one iteration of this while loop, you don't do anything, you don't have any forward progress, then it means that you're stuck, and unfortunately it means that the problem is impossible. So these are the two ways of exiting the main loop. And now inside the main loop, every time you want to remember to set made progress to false, and now only if you find an opportunity to make progress, then you will set this back to true, so that you will keep iterating. Okay, and now what you do is actually really simple. Like all it takes is just go through every index, literally in the string, right? So just go through every index, and at every step we want to check if we can remove one stamp. So here I have a comment that says the main idea. So instead of adding stamps from an empty string to the target, we remove stamps from a target string to empty string or placeholder string or whatever. And the key idea here is the reason for which you can do this at any given opportunity. So you don't need any strategy at all. You can just check, okay, can I remove a stamp right now? And if so, then you can do it straight away without checking anything else. And the reason for that is because any stamp that is stamped later, so like the last stamp, just covers all of the earlier ones. And so because of that, you don't care at all after you've removed it. You can do anything with the characters that are under that stamp, right? Because you're going to override them anyway. And so that means that removing a stamp is never going to hurt you, because it is not limiting your possibilities, your strategy in any way. So you start with a target which is like AB, ABCD, and you remove the last ABCD because your stamp is like ABCD, right? Well, that doesn't limit your options with the characters that are before it, because now you're just saying, okay, I will overwrite it with a stamp later on. So you can now do anything. So in fact, at any point where you remove a stamp, you're actually making more room for improvements, right? So yeah, at any opportunity, you always want to remove the stamp if it is possible to do so, because you're not limiting your options, you're not creating a dead end for your strategy, and you're actually improving your options, because now you have all of those extra characters that you know that are going to get overwritten to work with, okay? And yeah, here I just have an analogy with the z-index property, CSS property. But anyway, and then we have the visited array, which, as I said, we just set it to true. So if we've stamped something, so we removed a stamp from the index I, then we set visited of I to true, so that we don't remove a stamp from there again. Or, yeah, because that would be useless. And it's actually important. I will get back to why this is actually needed later on. Okay, so now what we're going to do is we're going to check if the current index has not been visited yet. And if it has not been visited yet, we check if we can replace at the current index the target with our stamp. So we can remove the stamp from the current target string at this index. And if so, then we're going to implement this later on, right? But anyway, if we can replace at the current index, then we do so. So we do the replacement. And again, we're going to see this function later on. But the key here is, again, that we can be greedy whenever we can replace, and we haven't done that already in the same index, because that would be useless repetition. Whenever we can, we do so. Okay, this is the key idea. And that's because I have already explained before why this never hurts you. It doesn't ever bring you to a dead end. Okay? And then, since you've just made a replacement, you want to set your progress to true, because you don't want to exit the loop, because you did something, right? So maybe in the next iteration, this leaves you with more options and you can do something again. Okay? And then you want to set your visited of I to true so that you don't do this one again, because that would be just a complete loop and it wouldn't be useful. And then you want to push to your result this current index, because that's just the format that the problem wants the answer. So the problem wants the list of the stamps that you need to do in order to get to the target. And at the end, we will actually reverse the result. So we're pushing them at the end, and then we reverse, and this has a better time complexity than just unshifting the indices. Okay, and the other thing here to note is that if we haven't made any progress, meaning that instead of exiting from here, we've actually took this exit. So made progress was false. So we exited the while loop, so we get here. So if we haven't made any progress, return empty array, which is just the problem way of saying there is no answer. But otherwise, if we have exited the while loop because to do got to 0, then we return the result reversed. Because remember, here we are removing stamps and they want the order to add the stamps. Okay, so now all that's left, if you get the idea here, then these two functions are going to be really simple. So the main part of the problem is really this loop. And now these two functions are nothing smart, like they're just checking if you can remove a stamp from the index and then actually doing it. So yeah, it's nothing smart really. And also don't forget to update your to-do variable inside of these functions, or like in any way you want. I do it inside of the functions. Okay, so the can replace function is really simple. All you do is you just loop through you start from your index that is passed as a parameter, and then you loop through all of the indices in the stamp length, and you move forward both in the stamp and in your target string, because the index there is different, right? So you move forward with both pointers, with both iterators, and then at every step you check if the target index is different from star, meaning that you don't know what, like if it was a star, so when target is a star, it means that anything can go there because it's going to get overwritten anyway. So if it is not a star, then it means that we need a specific letter there. And if we need a specific letter there, and the letter is different from the letter that we have in the stamp, then unfortunately it means that we cannot replace, we cannot take away the current stamp from the target. And so there we need to return false. But if we never end up in this condition, then it means that we can return true. So after we visit all of the stamp and we check that either all of the characters are equal, or where they are not equal, there is a star in the target. So it means that it's going to get overwritten anyway, so might as well remove a stamp anyway, right? So in that case, we can return true. But if we find that one letter in the target is different and it is not a star, it means that we cannot remove a stamp from there. It's not ready. Okay, and now the other function is doReplace, which kind of does a very similar thing. So doReplace, again, takes as an input the index where you want to start removing the stamp. And then you want to count the amount of characters that you have replaced, because then you want to remove them from to-do. Okay, so what you do is loop through the length of the stamp again, so it's very similar. And then at every step, if the target was not already a star, then you want to increment your replaced count. Because if it was already a star, you're not really decrementing your to-do amount, right? Because it was already done, so you're not progressing any forward. So instead, if it wasn't a star, then we want to decrease our to-do count. And then you just set your target at the current index to a star. So the next time, it's not going to get counted, and it's not going to result in returning false when we check if we can replace. Because now anything that is a star can be considered as a valid stamp target, because you know that you're going to overwrite it anyway, right? So this is the power of the star here. And then at the end, we just remove from the to-do count the amount of characters that we have replaced. And yeah, that's it. So I'll run the code to show you that it works. And the time complexity here is O of n squared times the stamp length. So so here you could be replacing like one character at a time or something like that. And in every iteration of the for loop, you might be checking O of stamp length. And so yeah, the total is 2 nested loops, which comes to target length squared. And inside of every iteration, you have can replace and do replace, which both take O of n, where n is the length of the stamp. So that's it from me today. Thank you for watching, and bye.